Before we look at example 3, I just want to make a final comment about example 2 that I didn't make before. And that is, I had said that you could choose anything that you want for this point P, as long as, of course, the y-coordinate is 0, because it has to be on the x-axis. But what if I had chosen, say, 7 here? What if I had chosen the point 7, 0 for my point? Then notice that that would have just changed these to 7s, and so it would have been 0 over 7, it still would have been 0. Here it would have been 7 over 7, it still would have been 1. Here it would have been 0 over 7, it still would have been 0. And then these, of course, would have changed correspondingly. So it wouldn't have changed any of the final answers. And that's an important point to make because we're going to see that in the next example. For example 3, I'm actually going to change this. Instead of pi over 3, I want theta to be 2 pi over 3. And we can even envision where that angle is. We know 2 pi over 3 is right here in the rotation diagram. All right, and we're supposed to evaluate, if possible, the exact values of the 6 trig ratios for this particular angle. All right, so actually, let me make this a little bit larger. All right, so here is my angle of 2 pi over 3. So something like this, okay? And so then remember what I need to choose is some point on the terminal side, and I need to come up with a coordinate of that point. Well, we know something about this angle because we know that this is 2 pi over 3. And so we know that this angle that's right here has to be pi over 3. And why? Well, because that angle is pi, a half rotation, minus the 2 pi over 3 that we already have. So common denominator is 3, so 3 pi over 3, so that's pi over 3. Well, pi over 3, remember if I change that to degrees, is 180 degrees over pi for my conversion factor. The pi's cancel, and I get 60 degrees. So that tells me that this is a 60-degree angle, and of course this is 30, and then we've got our right angle right here. So remember that in a 30-60 right triangle, that the short leg is always x, the hypotenuse is 2x, and the long leg is x times the square root of 3. So this is why we spent all this time studying these, because these are going to be important. So when I go back over here to this triangle, I can choose anything that I want for this short leg because I'm trying to come up with this length right here. So let's suppose that I choose just 1 because that's a nice easy number. And so that means that this is 1. The hypotenuse then is 2 times 1, which is 2. So that means that this is 2. And then if I sub 1 in here, I get 1 times the square root of 3, so this side's just the square root of 3. So what that tells me about this point P is that is the point -1 square root of 3. Right? Because how did I get to that point? I went from the origin, back 1, and up square root of 3. So now I know that x is -1 and y is the square root of 3. And in fact, in doing this, I also know what r is. I don't even have to do any work to get that. R is 2. Remember, r is always positive. So then we just go through and do the same thing that we've done before. So the sine of 2 pi over 3 then is going to be y over r. And remember, I encourage you to write this just to practice it and to memorize it. So we get the square root of 3 over 2. The cosine of 2 pi over 3 then is x over r. So that's -1 over 2, so that's -1/2. The tangent of 2 pi over 3 is y over x, and so that's going to be the square root of 3 over -1, which is simply negative square root of 3. And then just like before, to find the reciprocal functions, cosecant, secant, and cotangent, cosecant of 2 pi over 3 is going to be the reciprocal of this, so it's going to be 2 over the square root of 3, but now we need to rationalize the denominator. So I'm going to multiply the numerator and denominator by the square root of 3. So I get 2 times the square root of 3 over 3. The secant of 2 pi over 3 is equal to the reciprocal of this, which is just -2, so that's nice and easy. And then the cotangent of 2 pi over 3 is just going to be -1 over the square root of 3. So that one we do have to rationalize. So I'll multiply the numerator and denominator by the square root of 3. And so we end up with negative square root of 3 over 3. Okay. Now, I just want to point out that if you had chosen this to be a different number, like if you had chosen this to be, say, 2, then this would have been 4, and this would have been 2 times the square root of 3. So that would have just doubled all of these numbers. So this would have been, x would have been -2. This would have been 2 times the square root of 3, and then this would have been 4. But then when you take the ratios are all going to be the same. So for instance, if I do the sign then as y over r, it would be 2 times the square root of 3 over 4, which will simplify to square root of 3 over 2. Okay, so we would have come up with the same answer, and this is the same for all of the ratios.